Today, we have a very established person as a keynote speaker for our conference, Dr. Gayatri Nagarajan. It gives me an immense pleasure to introduce her to all of you. As an acclaimed data scientist and mentor, her career spans robust academic research and strategic freelance consulting. She is well equipped to transform complex data into actionable insights and adapt at fostering the next wave of data science professionals. Her research works are published in high impact Scopus indexed tier journals with Elsewhere, Springer. Standing out in the data science field, her expertise bridge practical applications of machine learning with the academic powers demonstrated by multiple high impact journal publications. This dual strength is complemented by a dedication to mentorship, uniquely positioning her to educate and lead in a rapidly evolving industry. Her accomplishments range from developing prediction accuracy models across various sectors to mentoring graduates and corporate professionals, being recognized with awards such as Young Woman Researcher Educator and Best Researcher in Data Analytics. She brings a track record of excellence to any educational endeavor. She is also a technical interview panel member in private employment consultancies to hire data scientists and ML engineers, and also a member of Word Research Council. Her experience starts from a very early age in 2007, where she started working as a software engineer at Tata Consultancy Services in Bangalore, followed by as an R&D engineer at Yokogawa Engineering Asia Limited, Singapore. Then she also handed as an assistant professor at MBJ College of Engineering, Bangalore, followed by her PhD at VIT in University, India, and now currently she is working as a freelancer, a data scientist consultant in Germany. It's an honor to have you here, ma'am.
Thank you, Vanshika, ma'am. That's really a great introduction. Good morning to everyone. I'm Dr. Gayatri Nagarajan. So a small brief intro has been given by Vanshika, who had worked with me, who was my colleague in MBJ College of Engineering. It's nice to see some of my colleagues also in this conference after a very long time. To give a very small brief about myself, I'm currently working as an independent data science consultant in Germany. So I have done around 7 projects and currently working on my 8th project as with a network of colleagues, 2 based in US, 3 based in Europe, and 2 in India. My startup data science foundation made easy is also towards teaching incorporating data science education to corporate professionals who are seeking their career or moving or looking forward for a career transition towards data science, artificial intelligence, and Gen AI. Um, so let me let me start my session by giving an intro of Gen AI. So, Vanshika ma'am, can I start the session?
Yes, ma'am, you can please.
Thank you all for joining. And thank you, Vanshika ma'am and East Point College of Engineering for giving me an opportunity to share my knowledge. It has been my passion to always contribute towards education sector in India. So let me share my screen. Please let me know once you're able to see my screen.
Yeah, ma'am, it's visible.
Thank you. So my session today is on Introduction to Gen AI and its applications. So generative AI is the recent technique and technology which is most required in the job market as of now. So wherever you go, it's like Gen AI specialist, Gen AI engineer is what is required. So initially, it started with data science engineer and then data science consultant, then traditional AI, and now towards Gen AI. So my intention in this session is at the end of the session, the audience should be able to understand the difference between what is conventional AI and what is Gen AI. What are all the applications or business problems that require conventional AI, and what are all the business problems that need to use Gen AI models? What is exactly the difference, where to use this and where to use that, and what is the basic foundation of generative AI models? So how it works, what is the technology behind it, what are all the models that are behind it, what is the technique behind it, and what are the challenges and limitations in Gen AI too, which will be very useful for academic professionals who are actually ready to work on Gen AI, pursue Gen AI as the research topic, and try to solve some problems or write some papers to overcome those challenges. So let me start. This is my content slide, where first initially I'll begin with what is generative AI, and then followed by the difference between conventional AI and generative AI. What exactly is the difference? And next, the applications of Gen AI. Where do we actually use Gen AI? Followed by foundation of large language models, which is the basis of Gen AI, basic of Gen AI model. And then agents, an introduction to agents, so through which all the Gen AI models, like including chatbots or Gemini, everything works. And finally, coming to challenges and limitations, which will be of use mainly for researchers who are trying to work with Gen AI. So what is generative AI? So many of us are using, not many of us, all of us are actually using Gen AI models in our daily life. So what is Gen AI? Is it Chat GPT? Is it DeepSeek AI? Is it Gemini? What is it? So we are actually using all these things in our day-to-day life. Chat GPT is what we use normally to generate any text, right? So maybe when we are writing a paper, or even when we are building our resume, whatever it is, even when we are writing our research articles, even for code generation, we are using Chat GPT. And DeepSeek AI is the very recent model, which has actually originated from China. And Gemini is one more model, which is actually a Gen AI based model. And then there are many other base models like Copilot. So we talk, we come out with some automatic voice generation. When you use one language and you are in, say for example, in Germany, you're speaking in English and it is converted to German. When it has to be translated to a person who understands only German. So these are all because of Gen AI. What is behind all these techniques? So we use all these things, but what is behind all this is basically Gen AI, generative AI. So what is it actually? These are all models. You have heard of all these terms: Chat GPT, Gemini, DeepSeek AI, Copilot. These are all Gen AI models, based Gen AI models. So what is it actually? What is generative AI? Generative AI, as the name suggests, it generates something. So what does it basically generate? It generates text. It can generate text. It can generate images. It can generate video. It can generate audio. And it can also generate code. Code is again based on text, right? So code is again text, and it can generate all these things. It's not only a particular text alone is being generated. It can also generate images, videos, audios, whatever it is. It can generate many things. This is basically a multimodal thing. You call it as multimodal. Initially, the first model started only with generation of text. Then the next model, maybe they developed other model which generated only images, other model which generated only audio, and one other which generated only video. And the recent Gen AI models, including the latest GPT-4 Turbo, that has a multimodal feature which can generate everything: text, image, audio, video, everything. So basically, what it does is it learns and it decides exactly like our human brain. So how does our brain works? So it works exactly in the same way. Say for example, I'm giving you a logical puzzle. So I have 13 coins, in which one is odd, one has an odd weight, one is odd in terms of weight. So all the 13 coins are not of equal weights, and only 12 are of the same weight, and one is odd, which is either overweight or underweight. So in just two weighings, I need to find out which is having the abnormal weight. I mean, which coin is odd. So how do you think? How does our brain think? So just two weighings, I need to find out which coin is odd. Is there anybody who can answer this puzzle? So I have 13 different coins. In just two weighings, I have to find out which coin is odd. Okay, uh, not an issue. If you put this in your Gen AI, if you have this puzzle, if you ask this in Copilot or any Gen AI models, it will give you the answer. What are all the steps? How you can do that? So the same thing, how our human brain thinks it. So take it as 4 4 and have other five in your hand. That will be your first weighing. So if both the four pans are of equal, meaning all the eight are of equal weights, then what is that in your hand? That five is the one that is having the odd weight. Then in the next weighing, you could take it out, next two and split one. If this two are having abnormal weight, then how does it work? Then find out. So you basically divide it into three categories. You then do one weighing and sub. It's broken down into a sub problem. Find out the first four or five, which contains the odd one. The next weighing, you will find out the next two or three, which is having the odd one. That is how it works. So this is exactly how Gen AI model works. So you need not think itself. You need not think using your brain. How can I do it in two weighings? How can I do it in three weighings? You just type this puzzle, logical puzzle in your model, you will get your answer. This is not something that can be done by conventional AI. This is something that can be done only by generative AI. So generative AI is basically doesn't only generate text, images, video, audio, or multimodal things. It can also think like a human brain. It can solve any of your logical puzzles, or it can solve any of your problems. It can answer to any of your queries, whatever it is. Few of the popular interfaces of Gen AI include ChatGPT, Gemini, Copilot, DeepSeek AI. These are many popular interfaces that we commonly use today. So I want to book a hotel. I want to book a hotel for a family of four near beach in, say, for example, Bhubaneswar. So we just type the question. We are getting all the recommendations. So all this are done by Gen AI models. And who are all the major AI vendors in business today? OpenAI, number one. Then Google, they come out with their own products. Microsoft, who compete with all this OpenAI and Google, and they are also becoming. They are also coming out with their new creative models. So it has become a billion, trillion, zillion dollar industry recently. In just a couple of years, GenAI models have yielded a $1 zillion in your share markets, in your for your companies, and there is a heavy competition among the AI vendors who is coming out with different things. Say, for example, one company is coming out only with a text generation model or code generation model. The other company is trying to improve that, compete with it by coming out, by incorporating that along with something new. Say, for example, I can do image generation also along with this. So that is how the major AI vendors are playing their role and competing in their market. So Gen AI is the talk of the day today, and it is, and almost everybody who is into this field have to update themselves with generative AI. Otherwise, they cannot survive in this industry. Uh, and hence, I have taken this topic to give a brief introduction about what it is, how to actually get into this field or update yourself. So you could see what is actually happening behind. So what is actually Gen AI? So Gen AI is actually using existing information and creates vector space. So you're having some information, right? You're having a database, you're having some information. So you're having it as text, or you're having it as image, or you're having it as video, whatever it is, whatever type of data that you are having, notes, whatever it is an existing information and you have it. So computers, as you know, they all like playing with numbers. And Gen AI is of no difference between this. So AI, Gen AI, everything can play well with numbers only. So what it does is it converts this text, images, or video, whatever it is, into numbers. These are called vectors. There is a vector space. This process is called embedding. So basically, if you see a text, for example, you're writing something like, "I'm this person. I would like to do this. This are my hobbies. This is my experience. This and that." So all this information is basically converted into vector spaces, zeros, ones, twos, or numbers, typically numbers. So this process is done by what you call it as normalization, which is quite normal in converting this text. And then comes the tokenization. You might have heard of all these topics in your natural language processing. Normal tokenizer, stop word removals, all these things are happening. And after tokenization, these are tokens are all assigned as numbers. They are all converted as numbers and kept as vector spaces. And next, what happens is, see this, you would see that all the text is being converted into vector spaces, that is numbers. And then using so now what the vector spaces contain is like, for example, I saw a tiger in a jungle. It was thirsty. You could see this text. I saw a tiger in a jungle. It was thirsty. It came to the river. So here it means the tiger, right? So the tiger I saw in a jungle. Everything is converted as numbers. So the tiger is same as it. It means it represents tiger. The context of it here represents the noun tiger. So it is nothing but a tiger here. It's not a jungle. It's not you. It's the tiger which it means. So the vector space is having the information that it represents the tiger here. So that is basically the text are converted into tokens, and then the tokens are assigned values. They are assigned numbers, vectors. So the vectors not only or merely representation of the words, but they also represent the contextual information. They also show which word is related to which word under which context. So this is closely related. It represents tiger. Okay, fine. So these two are closely related. These two are not at all related. So thirsty, forest, not related. So that is how it works. Thirsty tiger, yes. The tiger is the one that was thirsty. So this information, this contextual information is basically embedded as vector spaces. And then the Gen AI model captures this vector space. It takes this information and then it generates your text based on the prompt that you're giving. Say, for example, you're giving a prompt. I want to buy a branded T-shirt nearby this particular location. So what it does is it sees this. It has the existing information as vector spaces. It will see. So what is your prompt? Near Whitefield. Okay, choose that particular keyword. So what are all the shops? What are all the retail shops? So what do you want to buy? T-shirt. Okay, menswear. What is that? Then it generates the text. You can have the following options. Number one, so this particular shop. Number two, this particular shop based on the ratings. So it generates the text. So when you're writing, you want to write an article. Say for example, I want to write an article on Gen AI. Give me a short summary of what Gen AI is. Then it generates. Gen AI is an AI model, is an improvement of AI version which can generate this. So how it generates the next token, how it generates the text. The same way it generates the images, it generates video. As I told you, it is multimodal. So the information from which it generates is typically present in the vector space. So this is not how traditional AI works. So remember that traditional AI has some existing information as your training data set, and then you're feeding the testing data set. Based on this existing information, it will classify or it will predict or it will cluster or whatever is your business problem, accordingly it will behave. Sentiment analysis or whatever it is. But in case of Gen AI, it takes this information, it uses the contextual information, and then it generates the text. It generates the text, it generates the images, everything. So this is how it works. So based on the prompt using the vector spaces, prompt is nothing but your user input. The input that you are giving, the question that you are basically asking to the Gen AI model is what is termed as prompt. And the answer that you're getting from the Gen AI model is technically called as response. So what is the difference between conventional and traditional AI? So as I had mentioned you earlier, traditional AI is what all your models that you are aware of, KNN, SVM, then neural networks, feed-forward neural networks, RNNs, LSTMs, all these things you may be aware of, how it works, everything. So now traditional AI, basically if you take, it can be used for classification problem. Say for example, I want to classify whether this particular patient's data says it is a benign cancer or it's a malignant cancer. So it gets trained on the data. So depending on some, say for example, I'm giving some 5,000 patients information. Then it got my AI model has been trained based on this 5,000 patients information. Now I'm passing some new 10 patients information. So what happens based on this information and the training knowledge that it has acquired, it will classify the new patient as either having malignant cancer or benign cancer. That's how the traditional AI model works. Or else it can do prediction also. Say for example, this is how the rent prices are in Whitefield. So in 2004 it was like this, in 14 it was like this, in 24 it was like this. So how will it be in 2034? Those kinds of predictions based on the already existing information. This is time series. So all this can be done with your traditional AI. So doesn't mean that Gen AI cannot do these things. No, it can. It can do this traditional AI tasks also, but apart from that, it is fine tuned to generate its own contents. So, if you say, for example, if you start an article, if you want to write a story, I want to write the story of a crow and an old lady. So, once upon a time. So, traditional AI cannot write. There lived a crow, but Gen AI can write. So traditional AI, apart from whatever the things that traditional AI can do, Gen AI can also generate. It has its own reasoning knowledge. It generates, it creates data on its own. So how is it different in classification? To explain it more clearly, so as I told you, in traditional AI, you have 5,000 patient records. I'm giving the new 10 patients record. Based on this 5,000, it will predict it, right? Whereas in the case of Gen AI, this 10 it will generate, apart from the 5,000 patient record, it will generate new data. It can generate new data, and this 10 patients records, when you pass, based on the synthetic data sets also, it analyzes. It has already generated data, and then it compares, and then it gives you the output. So this can also be used for classification, prediction, clustering, or natural language processing tasks. Apart from that, this can also be used for generating your text and other multimodal things. So one more example is chess. If you take chess, if you play a game of chess with a computer, so how does it work? So you're giving a move, and then the computer will give its move. So that is based on AI. There are some strategic rules, strategies, and rules are defined at the back. So this is how a check is given to this king. So the next move should be move this king to this side, that side. So that is a rule that is already inbuilt in the conventional AI. So if for this case, Gen AI is not required. It's absolutely not required because it is not going to generate any new information. Your AI, your model is going to play only based on the existing information or traditional information that it already has, existing knowledge that it already has. So for in this case, Gen AI is absolutely not required as long as the game doesn't require any new generation or any creative strategies. Whereas in the case of story writing, your traditional AI cannot work. It is not having any existing information to, and it cannot generate on its own. Whereas Gen AI model can generate on its own, and for story writing tasks, Gen AI model is preferred. Gen AI model only can work. Traditional AI model cannot work. Whereas in the case of games like chess, which has strategic rules already defined, where existing knowledge or existing information is much more sufficient to play, then traditional AI is the best option to choose. But games can also be modified to use Gen AI model, where it can also create its own strategies. That is a next step ahead. But to the best, if it is going to work on some strategies and rules that is already existing, then traditional AI is the best one. If something is going to generate a new one, then or create its own, then Gen AI is the best one. So that's what I have given. So if something is confined to the strategies, then traditional AI is the best one. If something has to develop a new solution, if your business problem has to develop a new solution, then Gen AI is the one. And based on data input, so we are getting the difference between conventional AI and Gen AI. So based on data input, how they differ. So you see, traditional AI, you're basically doing it for a particular business problem. Say, for example, a healthcare data set, or for example, an education sector, or for example, a financial sector. You have input from based on that particular business problem. You have a company's database. You have that database as input. Then you're recruiting a new employee for that company. You're analyzing the risk. How long will the employee stay with me? How long can I retain him? So based on that classification or clustering, whatever it is, it works. So that is in terms of traditional AI, where the input is limited or restricted to that particular business area. But in the case of Gen AI, your data set, your model is actually trained on billions of data sets. A best example is book corpus data set. Your text generation model, text generation model like Chat GPT, is all trained on book corpus data sets, which is like it has billions of data sets in it. So it is not confined or specific to a particular business problem. It is generalized to many business problems. You can use it for financial sector. You can use it for retail sector. You can use the same model for one other sector also, healthcare sector also. So the data input is very small in case of conventional AI, restricted to a particular or constrained to a particular business problem. Whereas in case of Gen AI, since it is generalized, your model is already being trained with millions or billions of data sets, or corpus data sets. I told you ChatGPT is trained on book corpus data set. The same way you have some whisper model that is for image data set. A code generation model is trained on GitHub. So, so all this are like vast of data, big amount of data. Basically developing a Gen AI model from the scratch will take many weeks even to train the model. So we are just going to actually fine tune it for our industry specific needs. And secondly, when it comes to time savings, we prefer conventional AI model whenever the business problem is easy to handle. I mean, if it can be handled, if the problem is easy to be solved using traditional AI methods itself, we always prefer going for traditional AI, not Gen AI. Just because of fancy term, or just because I'm working in Gen AI, we need to use only Gen AI, nothing of that concept. As long as it can be solved using traditional AI, it's best to go for traditional AI methods. Whereas if your data set or if your business problem really requires some generation or creativity, then it is better to go for Gen AI model, because um, training a Gen AI model is very difficult. Since it is already trained, fine tuning will be easy. So in case of some other business problem, say for example, you're just going to have a question answering system, a chatbot system with an airline. Say for example, Lufthansa Airlines, you just need to check, do I have, can I get a window seat on this particular day from this place to this destination in this airlines. So this is a normal prompt, normal user input. So this doesn't require any fine tuning of your model. A basic Gen AI model can itself answer this question, can itself respond to this question. In that case, there is no training required. So we prefer going for Gen AI model because you can just fine tune it. The time is saved here. Whereas if it is a conventional AI model which is developed for a particular domain, say for example, if it is for I'm having this skin itching, red patchy skin, so all these things. So I'm just giving the symptom. I have to generate the output, and it should be perfect. If it needs to be very perfect output, see if it is just A normal Gen AI model, if you pick up, it will give you it will give you the response or answer as you have skin allergy, use these medications. But if it is a proper traditional AI that is developed specific to this particular business need, that is for healthcare sector, then it will give you the exact name. This is called hypopigmentation, or this is acute dermatitis. For this, you have to use these things. So this much of oral medication you should take. This is the moisturizer that you prefer. This are the dermatologists that you have nearby. You can consult them if it persists for this many times. So it can give you a more detailed thing. In this case, traditional model is preferred because you need a very clear, detailed information. So this is basically the difference. So if you are going to just use it for some simple things, you just need a proper answer for some simple things, it's better to go for Gen AI model because only fine tuning is required and you can do it with a basic model itself. But if you need to develop a particular system right from the scratch specific to that particular domain, it should be very specific for that business problem, then it is better to go for traditional AI because training will happen and then it will give you the proper information. So training will not also take more time in case of traditional AI when compared with the Gen AI model. But fine tuning is much easier in Gen AI than in traditional model. This is the difference in terms of time savings. And creativity, as I had already mentioned, traditional AI is used for merely classification, clustering, prediction. It can be a little bit extended to natural language processing, but not that much like generation. Whereas Gen AI is generative model, completely generative. It generates everything on your own. Nowadays, nobody is using even coding. Nobody is actually coding. So whenever we hire for data scientist or AI, nobody is asking us to check for any Python related coding stuffs or something because everything is done by Gen AI. As long as you are able to understand the code and you are able to debug the code, and they are able to work with the model, find out which model is the best for this particular business problem, analyze that thing much more well and good. So only the conceptual knowledge is what we are looking for. Since the Gen AI has actually modified, I can't say that it has completely taken out the job of a programmer. Still exists. The Gen AI needs to be trained only by a programmer, but it has reduced the jobs of the programmer. So the number of, if there are 50,000 programmers in a particular company during, 5 years back, now with only 5,000 programmers, we can execute the same task using Gen AI model. That is how the present industry works. And language translation is another example where you would understand the difference very clearly. See, in case of traditional AI, it is rule based, so completely rule based. Whereas in case of Gen AI, it is how a human think, human like. Say for some example, some particular context, I say small drops make a big ocean. In case of rule-based AI, which is conventional AI, which is done by conventional traditional AI algorithms like your KNN or SVM or a normal neural network or even deep neural network model, what it will do is small drops make a big ocean. So it doesn't relate anything with the context. It just says like what you say in your own language, it just translates it merely. It's a small drops, they combine together and they make a big ocean. But in the case of Gen AI, it thinks like how a human thinks. Small drops make a big ocean. So in this case, in this context especially, this refers something like small savings will account to huge savings, will account to big savings. This is what he actually means. Or small sins will lead to big crime. So this is what it actually means. So what is that particular context? What is the particular paragraph telling about? What is the particular article telling about? So it translates it according to the particular article, according to the context. So it's not a mere translation. This is the difference to understand clearly between traditional AI and Gen AI. So traditional AI is just like you make a rule and you make strategies. You derive some rules based on which it merely works. It just generates the output. Whereas in case of Gen AI models, it thinks, it does some logical reasoning. It it does everything based on the context. how it has to be. So the contextual information is extracted in Gen AI. So this is the basic difference. And the next, if you go into deep, like accuracy differences will be there. So as I told you, when a business model when a business problem can be solved using conventional AI, it's always better to go for conventional AI because that gives you more accurate information, as it has been developed only for the particular sector, only for the particular domain, only with that particular training data. But in case of Gen AI, since it has been trained on overall on all the data sets, I mean, book corpus data set is something that is a vast million of information. You can go and search what does a book corpus data set contain when it comes to text generation model. So here, so if you're asking for a particular domain, your business problem is for a particular domain, it may not yield you the correct accuracy because Gen AI is a more generalized model. It is not very specific for that particular problem. So if it can be solved using conventional AI, better to go for conventional AI. But if it involves any generation of new content, then traditional AI will not work, and you have to choose Gen AI model. And when it comes to flexibility, so traditional AI is always, as I told you, is limited to predefined rules, strategies. If your chess game is developed based on traditional AI, so there are some strategies from some rules based on which it works. It cannot cope up with the new changes. Whereas in case of Gen AI, it adapts itself to new tasks. So since it can create its own content, since it can generate its own content, it can generate its own strategy, like how a human thinks the same way it thinks. So it is more flexible. Gen AI models are more flexible than traditional AI models, which are built for that exclusively for that particular business problem. And potential for misuse, obviously everybody knows this. It's more with Gen AI than with traditional AI. So even recently, malicious codes has been generated by Gen AI, which has cracked many systems, and it has become a very big cybercrime. So when it comes to difference between conventional and traditional, I mean Gen AI, these are the main differences. Traditional is mainly used for classification, clustering, and prediction on the training based on the training data that you are giving as input. Gen AI is a generalized model which can be fine-tuned to generate your own contents. But when it is for a specific business problem where you need to get a perfect, accurate results, then better to go for Gen AI model. But when your business problem involves generating new contents, maybe text or maybe images or audios, whatever it is, then better to go for Gen AI model. When it comes to creativity, your Gen AI is a rank ahead of your conventional AI. So language translation task I told you as an example. So it can be done both with conventional and with the Gen AI. But with conventional, it is restricted. It is rule based. It can just translate it. So it's been I'm a student. So that is in German. So I am a student. That is in English. But the context of it is actually extracted by Gen AI model. So it has a human reasoning and thinking capability, and Gen AI is more prone to misuse. So now I'm showing you a screen. This is time for you to think. So I've given some 6 problems. So it would be good if anybody or any of you can tell me whether it's better. The first problem can be approached with traditional or Gen AI. The same way, all the 6 problems are there. Which model is better to use, traditional or Gen AI, or which can be used, which cannot be used? It would be great if you could answer the question. If some of you could answer the question to ensure that you have understood the differences, where to use where very clearly. Identify the number one, identify through public comments if people are towards the government's decision or against it. So there are some public comments in your Facebook or, for example, Twitter or Instagram, whatever it is. You're just taking all these comments. You're going to classify or you're going to identify whether people or supportive to government's decision in this case, or they are against to this decision. So all these comments are for government's decision. I do agree for it. I do not agree for it. Or some other comments. They will not actually mention as I do agree or I don't agree. Also, they may be writing something else also in some paragraphs also, which for which the context will be either towards or against. So which one do you think is good in this case? Whether you can go for a traditional classification algorithm, or you can go for a generative AI, or you can go for both.
I think here we can go with the traditional AI,
Yes,
because it's a normal predicting classification that we are doing. So I think we can go with the traditional AI for the first case.
yes, exactly. Because it's a natural language processing task which can merely be executed with your any classification, very normal classification, sentiment analysis models itself. Number two is summarize a long PDF file. I'm giving you a very long PDF file of about 15-page document. Now, I'm asking your model, I need a model which could summarize it and give me a crisp of about 1 page with all the contents. I mean, the necessary contents. So, which model do you think will work for this?
I think here we can go with the Gen AI,
Yes.
because this will just brief the content here. So we used to use the traditional AI also for such problems earlier, but now Gen AI will give us more precise content in this case.
Yes, we have to use GenAI because it is summarizing. So this is an encoder decoder model when it comes to GenAI model. So it has to understand the text, extract the contextual information, and it has to generate on its own. It has the summarization is not exactly just copying and pasting from the main file, right? So it has to understand the context and it has to give a summary of it. So where it has to use its own words, at the same time it should not lose its meaning also. So in this case GenAI model is what is preferred because what can be used actually, what should be used actually, because that is the one which can think based on the context and it can generate the output. The third one is creating a marketing campaign poster. So for example, if there is a phone, there is a new phone company that is going to open, they are going to create a marketing campaign poster. So, which AI model do you think will work better? A normal, traditional, or conventional? I mean, or Gen AI?
I think this is something that we are currently using, so we should go with the Gen AI model, because right now this is what we are preferring to use.
Correct, correct. Because this is again generating an image. So, image generation, a very basic Gen AI model will do for it. No need to even to fine tune it. A very basic Gen AI image model can work on it. And then the fourth one, divide the customers in a retail store as frequent visitors and infrequent visitors. They are not frequently coming. So there is a retail store. You're visiting the retail store, or you frequent, or you're not visiting frequently.
I think here the traditional AI, ma'am.
Yes, traditional AI, very normal traditional AI, any classification model, including SVM, can work here. Then develop a game, maybe any game, as you say, football or chess or whatever it is.
Gen AI, madam.
Gen AI is much preferred, but it can also be done using conventional AI. But we prefer Gen AI nowadays because Gen AI can also make its own strategies. It can generate its own strategies. That's why. And finally, develop a question answer chatbot system for airline customers. One of the project that even I did recently. A question answer chatbot system for airline customers.
Gen AI, ma'am.
Yes, Gen
Here we
AI.
can.
Because it has to generate the answers based on the prompt that you're giving it. Very good. So this is the difference between where to use conventional and where to use Gen AI. So what are the applications of Gen AI? So as most of you are aware, it generates text for marketing content. So nowadays all the marketing posters, even image generation is done using Gen AI and the text for that marketing. So high vocabulary words, at the same time impressive words and exact words which has the same meaning are all given by Gen AI model. So rather than we writing, we always prefer using Gen AI model for generating marketing content. Then summarize patient histories in healthcare. So instead of reading, say for example, a 5 year, 6 year history of the patient, we just upload it as a PDF file And GenAI model is actually giving the summary of the patient's history. So only the important information or the keywords that it picks from the document file, it understands the context and then summarize it and then give it to you as a summary. So this is another application of GenAI model, which is followed not only in healthcare system, in all other systems where you don't have enough time to read a PDF file. A doctor might not be having enough time to read your 20-page document or 15 page of your patient's history. So they just use the basic GenAI model, which summarizes it and gives it. So depending on the keywords, the doctor can prescribe or recommend. So writing articles, which we ourselves do, essays, even school kids are using GenAI model, which we are aware of. Academics, research industry, blog articles. Even I write blog articles based on using GenAI model only. And smart search. So as I told you, booking. So I need a hotel. I need a farmhouse kind of hotel in this particular place. Say for example in Mangalore for a family of 8. So how much ever input you're giving, whatever is the prompt that you are giving exactly. So the GenAI at the back searches for it and it fetches the right content for you. It gives you the right recommendations. So it gives you the answers only for the farmhouse hotels, only in Bangalore, only where it can accommodate 8. So that smart searching is being done by GenAI models. That I will give you a crisp intro about how it actually does at the back through APIs and other things. Then text generation is also like a chatbot question answering system for customer service, which where call centers and BPOs people are actually replaced by the chatbot systems nowadays. So people are selling this chatbots. Many companies are selling this chatbots for airline customers, banking customers. So even hospitals, even in whatever is the business it is. So chatbot question answering system is very common. I can book an appointment with a doctor immediately using chatbot, right? So these are all product of sales in today's market. And product recommendation system. So based on what you want, the t-shirt and this size and this particular brand and what is your purchase history previously. So it tracks all this and what is the availability in the store at present. So it does a background search of all this information and then it gives you the recommendation. So this is where you can buy. So these are the places, these are the offers, these are the rates, these are the brands. So it gives a very clear descriptions, a recommendation system for you. So these are all examples for usage of text generation AIs. So AI models which are based on text generation. So as I had already told you, they are all trained on very big data sets like book corpus data sets. And this and a very good example of this text generation is ChatGPT, Llama model. All these are open source AI models that are in use today. And image generation. So image generation, where we use this is mainly, as I told you, generating posters for marketing campaign and medical hospital recently had even connected with us. So they have given the x-rays of few patients and scanned reports of these patients and they had asked us to predict after 1 year how will it be. So since GenAI model can also generate images, we can give these images as the input and slowly based on how it has developed, our GenAI model with a slight fine tuning of the exploitation and exploration trade-off, we were able to achieve how it will be like after 6 months. It was a small, what you say, brain. It was not exactly brain tumor thing on brain. So how it can develop in 6 months, how it can develop after 1 year. So how worst it can be after 2 years till 5 years. We had actually predicted it. So this was basically predicted based on the image generation of GenAI. We used a GenAI model, image generation model, through which we had predicted it, how it would how it would get was. So that is how not only for hospitals, for other images also we can use. So how it will be, including traffics. So how it can be. So that can be predicted. So after half an hour, how will the traffic in this particular place will be. So that can even be generated with GenAI model. And artists are mainly used for unique artworks. Many of the boutiques and fashion designing, interior designing, even product designing companies where they are manufacturing cars also, mechanical things also. they are generating images based on Gen AI models. And visual storytelling. So I write a story, even I don't write. I start it, I give the context, and even ChatGPT can write it. I can also generate images for that story. It's visual storytelling, which is more applied not only for small kids, but also for people like us. If we understand something that we see visually, it is much more getting into our brain than reading a text that is so long. So for visual storytelling, generating images is through Gen AI model. I just tell it like, give me an image where three members or where few colleagues are discussing in a meeting hall. So it generates an essay, generates an image. I just copy and paste it. So you could see this, there is a meeting that is happening. So I need not write it, there is a meeting that is happening. It's just an image through which you can understand what is happening. So whatever is your course, you only through generation of images you can understand even the course. So generate characters for games and movies. So this is all very common application of Gen AI model. So avatar, all this, the characters are being generated by basic Gen AI models. And then audio and video generation. So today, even the documentaries, if you see, uh, so when they are just reading or writing, or in case they are reading, they are telling something. So the automatically the subtitles are coming beneath the particular image or that particular video. So that is happening through Gen AI. So you're watching a movie in Telugu or in Hindi, and then the subtitles are generated in English. That is by means of Gen AI model. So how the automatic language translation is being done and it is generated. So speech to audio, audio generation, and then audio to text generation. So all these are very easy with Gen AI models. And even in music industry, you can create sound effects, you can create music contents using this Gen AI. Short videos, animations, presentations, and nowadays the courses, rather than Udemy and Coursera, rather than using instructors to generate the course contents, we are also asked to use Gen AI models where we could where we record everything and then we provide them. So the complete thing, the complete course is becoming visually appealing with its music effects, with its text effects, with the subtitles. Everything is being done. So through Gen AI models, it has become very easy because of its audio, video generation, text generation. And finally comes the code generation, software development. So we generally don't, it is not generally preferred to use Gen AI completely for your code. So being in a hiring panel also, what we see is, are you able to write even small pieces of code? At least small pieces of code we should write it. So the complete code generation by Gen AI is not preferred, though it can do it. So, but there is something called code completion. You can start, you can know it. So you will know what has to be done. Say, for example, I'm using RAG. What is the first thing that I had to do? Input the PDF file, take as input my PDF file. Code can be generated for that. What is the next thing that I have to do? So tokenize this using character tokening or word tokening, stemming, lemmatization, what I have to do. So embed this into vector spaces. That is my next thing. So I will write that, the code will be generated or the code will be completed based on that. I will write small codes. Then what should be done? Then RAG has to be, then the user query has to be taken in. So the basic model has to be called for. So using the query and the basic model, so I have to receive my prompt. So that is all like code completion. So it is not code generation, completely code generation. You should know the process, how it works. Okay, take it. Then you have to tokenize it. Then you have to embed it. Then you have to take the query. Then you have to, start the basic model. Then using the query, you mean using the prompt and the basic model, what is the response that is generated? If the response is not according to what you want, then how should the response be from the Gen AI? That is all is code completion. That is what is actually required now and seen in the industry, how the process works. So because the code is generated by Gen AI, so rather than complete code generation, we prefer code completion by you knowing the actual process, what is happening behind. And then code reviews. Initially, when we started our careers, we would have used 2-3 members of from our team to review our code. Okay, change this. This 10 pieces of code can be shrinked to just 2 lines of code. So this was actually done manually initially. But nowadays, Gen AI is doing your complete code review and it's giving code recommendation. There is a memory leak in this code. So you can correct it using this bug fixing, debugging. So everything is done by Gen AI. So it has actually reduced the job of a software engineer. I mean, a programmer actually, programmer, and only the actual thinking or the logical thinking is also being done by Gen AI. How to use it, on where to use it exactly. So what is the next step that needs to be done? Only that kind of thinking is what is expected in the industry right now. So even test cases are automatically generated by Gen AI, even test codes are automatically generated, and even test results are automatically generated, documents are automatically generated. So all this is being done by Gen AI models. So now coming to the foundation, I'll just touch a small foundation of LLM and agents, after which we will close this session, because if you get into deep into all these things, it's a big ocean. So I don't want to touch. I just want to touch only the keywords of it. So anybody who is interested can go into detail and learn from the courses or many PDF files or many blog articles, including Medium. Medium is one of the main source that I personally think is good for. So you can get into more details, how to write the codes, how they work, all these things. So basically, what is LLM? Large language models. So this is the foundation for generative AI model. So initially, it was natural language processing through which it started. The Gen AI model actually started. So in traditional AI, we have something called NLP, natural language processing tasks, where we do the tokenization, stemming, lemmatization, then we embed them, then finally we use many of the models that are used for NLP exclusively, RNN, LSTM. So later, we are greedy, right? Human beings are always greedy. So this is not enough for me. I want to generate text. I want to generate image. So just by classification, just understanding it is not enough. I have to do more. So that is where the thought of Gen AI or the commencement of Gen AI actually started. So LLM is actually predicting the probability of next token. What should come next? Once upon a. What should come next? Time. That time has more probability to come as the next token. So that is how large language model generates its text. So how it generates is like, say for example, generative AI model. Next, what should come in the next as your next word is will be having higher probability. Let's say for example 0.9. So it will put is there. The the cat jumps. What will be coming as the next probability? Over the wall, the bridge. So depending on what it should come, what the context is. So that is how it predicts the probability of the next token. Say for example, the most beautiful city in India is, it will predict the next token as, say for example, Bhubaneswar, Bangalore, or Wayanad, or whatever it is, or Delhi, whatever it is. So which one is having the highest probability, it will apply it. So how the probability is being calculated, how the scores are calculated, what is self-attention mechanism, how the query works, how the key query value pair works. So what is multi-head attention, all this you can learn at the back. But this is how basically it works. It predicts the probability of each token and which one takes the higher probability to come as the next token is being fetched and it is being put there. That is why at times when your chat GPT responds, it stops in between because it finds it's difficult to predict the next token. But then you may ask a question, like if that is the case for every the same question I'm receiving different answers, how is it possible in case of chat GPT or in any other text generation? That is because every time it is being run, apart from that probability, is it also induces a kind of randomness in your model. So a random, say for example, if it is 0.9 probability, 2 or 3 tokens are having and 0.8 probability is also some other token is having. It includes some kind of randomness and it fetches the token with 0.8, not the one with 0.9. So that is why the same question, when you are asking to the model at different times, it generates different outputs. So apart from probability, randomness is also introduced. That's how LLM behaves. And the basic model of LLM is n-gram table. So you might have heard what is n-gram, 2 gram, 3 gram. So how the two words are connected, how the three words relationships are connected. So, and the advanced model of LLM is transformer. Transformer is a very common terminology that is in use today. So transformer is the basis. How it generated is through LSTM. LSTM has come out of RNN, right? Recurrent neural networks, the output of the first layer is also being fed as the input for the next layer. It's a recurrent thing. So the basic problem with recurrent neural network in terms of natural language processing is sequential processing. It lacks the capability of parallel processing. And secondly, it has vanishing gradient problem. So you know what is vanishing gradient problem. So it calculates the network weights based on gradient and it goes and goes to the next layers. The gradient decreases and at one point it finally vanishes. That is vanishing gradient problem. So what happens is the model couldn't train itself, couldn't train more. It becomes stagnant at that particular place. This is a problem with RNN. These two are the main problems. And LSTM, long short-term memory, has evolved to solve this problem of vanishing gradient. It does this by identifying the long-term dependencies among the words. And that is how it works. But still, it cannot do parallel processing. It still can do only sequential processing. And then the transformers came. It can also do self-attention mechanism to capture the exact contextual relationships, and it also does parallel processing to overcome the problem that happened through RNN and LSTM. So transformer is the basic model for LLM. So it was basically the first transform model came in 2017. So there are still some models that are only encoder only model. There are some that are only decoder. There are some that are both encoder decoder. One example I can tell you is like, say for example, the cat jumped over the wall. The cat is being masked. Okay, now imagine the blank jumped over the wall. So I'm giving this as input. This blank will be filled with cat. So it is the cat that should come there. So if a model is giving that output correctly, that is encoder only model. So you already have given your text. Based on the context, it fill in the blanks correctly. So that is how an encoder model works. Decoder only is like it predicts the next token only. The cat jumped over the blank. So it will predict exactly that it is wall. So that is how decoder only model works. An encoder decoder is one where based on the contextual information, it can also predict blanks in between and it can also generate the next token. Say, for example, the summarization that we have seen earlier, a long PDF is being given, it has to summarize and it has to give a summary of how it, what the content, what the particular PDF is actually having. So that is, it has to also predict the next token. It also has to fill in the blanks with the right context, right contextual information. So in this case, encoder decoder model works. So BERT is a good example of encoder only model. So as I told you, many applications, ChatGPT is decoder. So many other applications like summarizations, all this are encoder decoder models. So slowly, every company came with its, every AI vendor came with their own models, with their improvements and all. So as I told you, basically how it works is it takes the input, it normalizes, it tokenizes, it embeds. Embed is just converting the tokens into vectors. And this vectors not only is just a mere numerical representation of the data, it also has contextual information. So how the tokens are related, thus that kind of information relationships is also represented by means of numbers. And then positional encoding is also done. So which key occupies which position also. And then comes the self-attention mechanism, which is very important in case of transformer. So queries, key, values, pair is how it works. You're giving a query for, say, for example, so which word is related more with this particular word? Say, for example, tiger. Then the keys, what are all the tokens that are related to it? then values. So every particular token is nothing but the word. Every particular word will be having a value also. So is it actually related to this, to whichever extent it is related. So I told you, right, that I saw a tiger in the jungle, it was thirsty. So this tiger and it or actually related to 100%, means they are the same thing. So it actually refers to tiger here. So that is how the self attention mechanism works. So how each is related to each other token, and it calculates the scores of each token by identifying the relationships. So what should come next? The most beautiful city in India is dash. What should come next? So it will have a score for each token. Delhi, it will have this, I mean, a value, a score. Say for example 70. Wayanad, say for example 90. So Bangalore, say for example 80. So what should I put next? That kind of score is assigned based on this pre-processing steps. And then this self-attention mechanism will identify the relationships clearly, and it calculates the score. And then your neural network, where your deep neural network comes to incorporate the non-linearity and complexity to your model. And then your model predicts the output, encoder only or decoder only or encoder decoder model, or whatever model that you are using. So basically, how is reasoning incorporated into LLM? A basic transformer model is not at all sufficient for your LLM. Reasoning capability should also be incorporated into it. There are three main ways by which reasoning is incorporated into LLM. The reasoning is nothing but thinking. So this is how the action has to be done. This is how the output has to be. So that is incorporated through three main strategies: through architecture design, through prompting strategies, and through training methodologies. So prompting is an important concept in LLM. So how prompt, as I told you, is the input to that particular model. So there are something like chain of thought, tree of thought, and least to most prompts. So chain of thought is like you have a basic model, and your basic model actually works for your business problem. Say I told you, right, what is 5 plus 5? It will give you the answer 10. It is a very basic model. You need not fine tune it. You need not do anything for it. So it is a zero shot model. Zero shot model is your base model will work for your problem without you fine tuning or giving any examples. Next is few shot. Few shot is like you're giving some example data to make the model understand how it should respond. Say for example, 5 plus 5 is 10 is what zero shot COT can do. So if I want the output in a particular format, for example, input 5, input 2, input 1, 5, input 2, 5, output 10. If I want in that particular format, then I will use few shot COT. So how I should require it? The same way I will input it. Input 5, output 10, input 7, input 5, output 12. So I'll pass these examples as training data to the model, to the base model. Then the next thing what I'll do is 6, 8. So what it will give you the output is input 6, input 2, 8, output 14. So according to the format that you require, it will give. So based on one or two examples, it will understand, the model will understand how you want the output to be, and it will give you the output in the same format that you expect it to be. That is that is what is called few shot chain of thought prompting. And then comes tree of thought prompting, which is used in game trees. So if I move king to this place, what are all the things that can happen? If I move the next step as bishop, what are all the things that can happen? So if I move this soldier to this place, this place, this place, what are all the things that can happen? So the same way like how a decision tree or a random forest works, there are many trees for the strategies. Say for example is game. So for the different strategy according to your business problem, and there will be a tree finally. So if I take this strategy, it will end up here. If I take this strategy, it will end up here. That is how your tree of thought works. And then comes least to most. So here what happens is the previous output will be used as a prompt for your next input. Say for example, I have ordered a t-shirt at for and in an online retail store and got it at 40% discount. I'm getting it for 18 euros, and I have purchased it for 18 euros. Now I have seen the advertisement the next day or 2 days later that I'm getting it for 60% discount. Now I'm asking my chatbot system, so can I return this t-shirt and can I get two other t-shirts for 50% discount for the same amount? So what it should do? It should first check, is the provision of returning available? So return is within the 30-day time period. Can I do that? So first, for the first question of yours, can I return the t-shirt that I had bought for 40%? Can I do that when you had bought it? So on this particular day, yes, you can return it. That is the first answer. Then that answer will become the input for the next one. So if I could return, so what is the amount that will be there in my credit? 18 euros. So for that 18 euros, can I buy two t-shirts? That will be your next prompt. Only if I could return, I'll get that 18 euros. Otherwise, I will not get it. So if it has exceeded 30-day period, it will say the answer is no. So when it comes to no, the answer is no. For the next set of questions, your input will be no. So you can't get another t-shirt for under two t-shirts for 50% discount. But if it is yes, then it will check in the database whether I can get any two t-shirts for 50% discount using this 18 euros. If yes, yes. If no, no. So for a chain of questions for which the previous output will be used as the input for the next one, least to most prompting strategy will be used in LLM. All this will be happening at the back, depending on your model. So training methods, few training methods like fine tuning, instruction tuning, oral HF is like a reinforcement learning using human feedback. So all this can also be used for LLM. So fine tuning is, for example, hospital patient reports. So you're having a basic model. So as I told you, I have this skin itching, I have the redness, inflammation. So it will just give you a skin allergy. But if you fine tune it with hospital and patient information, you're passing few examples of it to your database, then it will give you exactly, it is acute dermatitis. So it will give you exactly what is the ointment that have to be followed, what are all the doctors to be consulted. So that is the more generalized model is being fine-tuned to your particular business problem is fine-tuning in GenAI. And instruction tuning. So best example for instruction tuning is baking a bread. If I just ask my chat GPT like how do I bake a bread? So it will just give me answer in your home oven. But that is not what we want. So how do I need it? So take this flour, this wheat flour, this proportion, this maida flour, this proportion, then make it as a dough. Then have the oven's temperature as this much. Then you have to cut it like this. So all these particular steps need to be coming out, right? So that is instruction tuning. So you have to write the instructions. You can't just a normal generalized text generation cannot generate text for your thing that is required. So it should be incorporated with some instructions so that for this particular thing I have to give this instructions. And this instruction tuning is what is used for code generation. So if it is a Python code, this is the syntax. If it is a C++ code, this is the syntax. If it is a C hash code, this is the syntax. If it's an R code, this is the syntax. That is how it works. So this instruction tuning is also a way to achieve output for your to solve your business problem if it requires the instructions, proper instructions to be followed. And then reinforcement learning through human feedback is a reward model. So not only from understanding with the correct input, but also from understanding with the wrong outputs that it has done through human feedback. It will understand and learn itself, and then it will generate the output. So to be very clear, so I'm classifying a mark as okay, good. Your GenAI model has classified it as good. So, but a human, when he is asked, he's classifying it as very good. Then the GenAI model's reward point will be reduced because it has only classified it as good. So it understands. So if it is this, so that I have to calculate it as very good. That is how this human has calculated. So that is what is called reward. If it has calculated as very good, the human has also calculated as very good. The reward point will be improved. So that is also its knowledge, inbuilt knowledge for that particular system. So reward model, reinforcement learning through human feedback is also used. In case of Alexa, if you say, I'm in a very bad mood, you're telling to Alexa. So what is Alexa doing in a smart home? It is dimming off the lights. It is playing a light music. So that is all systems that have been developed with RLHF. And then few architecture designs, which you can go back and learn if you're interested. So knowledge distillation is basically using a parent model and transferring its knowledge to the child model. And exploitation, exploration, trade-off, dream search is all like temperature control and randomness. These are all parameter tuning. So see, your Gen AI model is actually tuned based on millions of parameters. So you're actually, they are trained based on millions of parameters. You're controlling some few parameters like temperature and all to adjust between exploration and exploitation, to make it more generative as exploration, to make it more generalized as exploration, to make it more specific is exploitation. So if your answer is coming as a more generalized version, then you should change the temperature accordingly to get it in a specific way. And if it is coming in a more specific way, you should adjust the temperature to come it in to get your answer in a more generalized way. And Gen AI also use something called tools to acquire real-time information. For example, you want a shopping recommendation for buying, say, for example, some saris. Then, apart from your purchase history, it should see what are all the local shops nearby, who are all selling saris, what are all the stocks available in their particular shops. So, apart from your information, it also has to get information from outside. If I want to book a flight, it should coordinate with the airlines to check if the flights are actually running on that particular day or if they are cancelled. So it should get information from outside. So this is actually incorporated in Gen AI by means of something called tools and agents. Agents or the applications that uses these tools to get external information or real-time information, and then use it for your Gen AI model to give you the desired output, to generate the desired output. Say, for example, I'm traveling to Orissa tomorrow. Then I'll ask, what is the travel recommendation? So tomorrow the weather is bad. So it will fetch the real-time information data, real-time weather data for Orissa for tomorrow, and it will check and will give the weather is bad. So don't go for Orissa for the next 1 week. So the recommendation, it has to fetch the real-time information, and accordingly it will act. So agents actually gather real-time information through tools, and they perform reasoning, and then they take action based on these tips. A good example of this is React RAGs. RAGs actually fetch retrieved augmented Gen AI, which actually fetches data from external PDFs or files or even databases. React also works in the same way. So without agents, LLMs work, but if some business problem requires real-time information, then the Gen AI model or that LLM actually requires agents. So if it doesn't require any real-time information, it is okay. It works based on the available training knowledge or existing knowledge it has. But if it requires to get real-time information also and then response to your prompt, then it requires something called agent, which has your model incorporated, which has tools in it, which has a reasoning logic in it. There are actually three types of tools. This is an example of extension. Extensions are there, then functions are there, then data stores are there. There's three different tools that are used to connect to the external information. So this is basically a bridge between your model and the external information, which is achieved by means of tools. And tools are actually operated by or run by an application called agent, which is incorporated in your model. So I want to book a flight to Mumbai. So what happens is it will search. So the flight, it will search for, the model is already trained, but that information is not sufficient. So some flights may have been cancelled, some flights have been rerouted, and some flights, depending on the weather, also you could give recommendation for the user. So this you can choose this flight because this has been cancelled. You can take this flight because this path is more secure at this point of time, and this is how the weather is. So you could avoid choosing a flight in the morning because of the weather. So this information, these APIs are called, these are external APIs which get real-time information from external database or external not only database, any files or even that company's database will be accessed, and then it will be output will be given back to the reasoning, and then it does some reasoning, and your model will be generating your output and then give you the recommendation for flights to Mumbai. So as I told you, there are three categories: extensions, functions, and data stores. How your model, your Gen AI model, fetches the real-time information available outside. So that is what tools do, and tools are actually operated by agents. So the basic difference among this is where the control lies. See, extension, in case of extension, if you're using extension, the control lies with the agents. But if you're using functions, the control lies in the client side. So this will be used especially for applications where um, some security is being provided in the API side to ensure that third party is not accessing yours. So they will not give access to the agents. Only client side can have access. Only arguments can be passed by the agents. And then data stores or racks, retrieved augmented generation frameworks, where it has access to PDF files or even external databases, and then it fetches the real-time information. So these are all some important functionalities behind how Gen AI model works. And what are the challenges or limitations? The first one is hallucination. So what your Gen AI model gives as output is maybe what exactly you wanted. See, it is hallucinated, meaning it can be fooled. It can be fooled because it is more generalized. Uh, so if I say, for example, give me a text plan about the war that is going to happen in 2026, a course plan for the war in 2076. See, 2076, we don't. It's in future. We don't even know whether there will be a war or not. You may a text plan to teach, a course plan to teach about the war that will happen in 2076 between India and Pakistan. So Gen AI will automatically generate a course plan, brief intro on the war. So what is behind this? So this particular day, a 1 week plan it will give you. But this is actually something that is what we say is a stupid thing. So what will happen in the future is something that we cannot predict, because it has been just trained. It just acts on what is happening. So but it is not exactly what the output has to be. The output has to be, it is in the near future, and we don't know what will happen. So this is called hallucination. Using the existing knowledge, it generates output, but that output is wrong. It is fooled. Gen AI model itself is being fooled. So this should be avoided. There are a lot of ways to avoid hallucination. Anybody who is interested in writing and pursuing research to avoid hallucination in Gen AI are most welcome. Then there is high potential for misuse of Gen AI. So even students in schools are writing articles. So even when we get resumes, we filter out few profiles who have completely used Gen AI for resume building. So it is something like you can't use Gen AI completely, or you can't trust Gen AI completely. Then it's a kind of misuse. So you have to use your own knowledge, but you can get help from or assistance from Gen AI, but you cannot use it completely, right? So there is high potential for misuse. And computational costs. So training Gen AI is quite costly. It consumes a lot of energy. It consumes a lot of time. So weeks and months of time to generate to build a Gen AI right from the scratch. Only fine tuning is what is done by industry people, and it's a black box. You don't know how it actually works at the back. How you just control the temperature. You just give some inputs as prompts, and it generates the output. So how it is generating is what is a big question mark. Unless and otherwise you develop a Gen AI model from scratch, you cannot understand it. And to be very frank, 85% of the people currently working in the industry do not know to generate to build a Gen AI right from the scratch. They only know to use the Gen AI models. So since that knowledge is lacking, we only know how to use it. It is a black box, and we cannot make our model work perfectly or give the output that we actually want it to be. And it is more generalized, as I say. It is more generalized. If you want a specific output, and it could be solved using traditional AI, it's well and good to go for traditional AI. This is a sample code for Gen AI. So how a rack works. So you're loading a document, your document.txt, you're splitting it, and then you're creating embeddings and vector space for it, and then you're retrieving the relevant chunks, how the text in the documents are related, which are all the documents that are related, which are all the texts that are related together. So what is the main topic discussed in the document? That is my query. The user is asking what is the, so I don't have time to read the complete document. That's why I have uploaded it to GenAI model. So what is the main topic that is discussed in this document? Summarize it. Or whatever my query is, it is giving that query, which is the prompt, and your base model chat GPT 3.5 turbo is generating the response for it, and then you're generating the response. This is how very normal basic code for GenAI exists, where I have not done any fine tuning. I have not adjusted any temperature. It's a very simple sample code of just taking a document and asking what is the main topic in this document. Yeah, so to be very crisp, so we had discussed about what is Gen AI. So what is the difference between conventional and Gen AI? So what are all the applications of Gen AI? Text generation, image generation, audio, video generation. So what are all the basic models? What are the AI vendors? What is the basic foundation, that is large language models for Gen AI? How they work? What is transformer? So how it has evolved, and yeah, what are the challenges and limitations? So what are agents, what are external tools, how GenAI actually takes external information or real-time information to generate the output that we want. So I had touched very lightly on the topics, but it's a vast ocean. As I had told you, if you want to go very deep into it, then you can always go deep into it based on the context or keywords that I had told. Say, for example, RAGs, prompt engineering, transformer, self-attention mechanism, all that you have, all that you can go inside it, and you can dig deep into it, and you can write your own code. So, any questions?
Thank you so much, ma'am. I think it gave us a brief insight into the world of generative AI today. And thank you for giving us your time all the way.
Thank you, Vanshika ma'am, and thank you for the great opportunity that I could contribute in some way to the education sector in
Thank you so
India.
much, ma'am. It's always a pleasure to meet you online right nowadays, rather. But thank you so much for giving us your time today. Thank you. Thank you, everyone.
Thank you.